in this chapter, we have the goal that we want to be able to say by the end of it that I can solve multi-step inequalities. This chapter really follows along with our last chapter with our solving linear equations. And the way that you solve inequalities is really basically the same way that you solve an equation. We're going to start off with kind of a quick question about what these are, what they mean, and that sort of stuff. So our question is, what do the following symbols mean? We all know that this is an equals to sign. Two things are the same. They are equivalent. The next one is a greater than symbol. That means that whatever is on the left-hand side is larger than whatever's on the right-hand side. The next symbol is a greater than or equal to symbol. That means that whatever's on the left-hand side of it is larger than whatever's on the right-hand side. Or it could be the same. Okay? So an example is we could have 7 being bigger than or equal to 6. We could have 7 being bigger than or equal to 7. Yes, I know that 7 is equal to 7, but it would still work with that inequality. Okay? Less than or equal. That's our next symbol. Whatever's on the left-hand side is smaller than whatever's on the right-hand side. This is all basic stuff that you guys have all seen before, so I'm not going to spend too much time with it. Then I'm going to actually rewrite this one. This one will be our strictly less than. Our less than symbol, whatever's on the left-hand side is strictly less than whatever's on the right-hand side. It has to be smaller than whatever's on the right-hand side. So an example could be like 6 is smaller than 7. Right? Whatever's on the left-hand side, smaller than the right-hand side, or equal. You guys should know what those mean, and so on. Okay, so let's actually get into solving a few inequalities. So our example says, solve and graph the following inequalities. We have 2x plus 8 is less than 3x plus 12. So we're just going to jump basically straight into it, head first, on how we solve linear inequalities. Well, the way that we solve inequalities is basically exactly the same as if we were solving an equation. There's just one thing that's different, and I will get to that in a moment. So with A, let's first make sure we have both sides simplified. They're already simplified. There's no fractions, there's no decimals, there's no parentheses. So we're good there. Let's go ahead and now get those variables together. Step 2, like we talked about yesterday. We can subtract the 2x on both sides or subtract the 3x on both sides. I'm going to subtract the 2x on both sides. Either way works, but you might have an extra little step if you did it the other way. So we have 8 is less than x plus 12. By the way, we are also going to graph our solutions as well. We have the variables on one side. Now what we're going to do is we are going to get the numbers to be all on the other side. So let's subtract by 12. So we end up with 8 minus by 12, which ends up to be a negative 4 is less than x. Generally, whenever we are writing our inequalities, we like to have x in front. We like to have the unknown first. So if we wanted to write it so that the unknown is first, we're going to write it as an x is larger, right? We want to make sure we flip the inequality as well, than negative 4. We're just moving stuff to the other side, flipping it around. Okay? So if we wanted to graph this, we're just going to graph it on a number line. For graphing, let's just put the negative 4 on there. Just put the negative 4 on the graph somewhere. It doesn't really matter. We could label other things on here. We could label a negative 3. We could label a negative 2. We can label a negative 1 if you really wanted to. But you really just need the piece of information for just that one number. So what we're going to do is now we are going to figure out how we actually graph it. Just a quick thing. If it is strictly bigger or strictly less than, if there's no equal to sign, the way we're going to graph it is we are going to put a circle with a hole in it. Okay? This means it cannot equal that number. If you put a hole in that graph, it cannot equal that. Okay? If you fill it in, it means it can. So it cannot equal this number. And it has to be bigger than, right? That's a greater than symbol. So it has to be bigger. Numbers that are bigger go to the right. Numbers that are smaller go to the left. That's basic math that you guys have seen before. So we go to the right. So graphing, it will look a lot like what we have on the screen. From -4, bigger. By the way, quick thing. If you write it with the X in front, the arrow tells you which direction to shade. It points to the right, so we shade to the right. Part B. Okay, with this one, same thing. We have our inequality. Let's go ahead and simplify both sides. Well, we have a fraction. Let's get rid of the fraction by multiplying by the denominator. Denominator is 4. So we multiply both sides by 4. We end up with x plus 4 is greater than or equal to, 125 times 4. That is going to be 500, right? 25 times 4 is 100. Then 1 times 4 is 400. 100 plus 400 is 500. So this would be 5.00, since there's 2 numbers behind the decimal. Okay, so in other words, that's just 5. Solve for x, so we subtract by 4. Subtract by 4, so x is bigger than or equal to 1. The nice thing is the x is already by itself. It's already on the left-hand side, which is nice. So all we have to do now is just graph it. So make our number line. Let's put 1 on this graph. Does not really matter where we put it. We can put some other numbers. We could put 2 on here. We could put 0 on here if we really want to, just to give a little bit of idea of where other numbers are. This one has equal to with it. So we're going to use a solid dot. A solid dot at 1. Everything bigger is to the right. Also, if you look at your inequality, with the x being first, the arrow points us to going to the right. So that's a nice little trick there. So that is our graph. That is our inequality. Part C. Part C has us doing a little bit of decimals. We're going to go ahead and clean this up a little bit by getting rid of the decimals. How we're going to get rid of the decimals, we have just one number behind the decimal. So in order to get rid of that, we just have to multiply by 10. Just multiply either 10, 100, 1,000. One with zeros behind it will move the decimal over. So we're going to take this side and the other side, multiply by 10, and that is going to get rid of our decimal. So we have a negative 660, x, minus by 24 is less than or equal to negative 12. You could work in the decimals if you really wanted to, or if you want to make it more simple without decimals or without fractions, that works as well. So what we're going to do now, we only have a variable on the left-hand side, so we're going to leave that over there. We are going to move the constant over to the other side. So we add 24 on both sides. So we have a negative 60, x less than equal to positive 12. Okay? From here, this is whenever we get to the one rule, which is our exception. We solve it exactly the same way as we solve an equation, except for if we multiply or divide by a negative. If we multiply or divide by a negative, then we have to flip the inequality. Okay? If we multiply or divide by a negative, we have to flip the inequality. So here we're going to be dividing by negative 60. Dividing by negative 60. Because we're dividing by negative 60, we have to take this inequality here, and we have to flip it. So instead of being a less than or equal to sign, this would now be a bigger than or equal to sign. So we now have x is bigger than or equal to whatever 12 divided by negative 60 is. So let's go ahead and do that division. 12 divided by negative 60, or by 60. 60 does not go into 12, so that's 0. We're going to end up putting a decimal. 60 into 120. And that is going to end up to be twice. So 0.2. Negative 0.2 would be where this is on our number line. By the way, if you wanted to write that as a fraction, that is x is bigger than or equal to a negative 1/5. Writing it our number line, We can either put the decimal or the fraction. Let's just put it over here. So this is negative 1/5, right at that spot. And it's closed because it can have the equal to sign. The x is first, so it tells us which direction we have to shade. We shade to the right because all the bigger numbers are to the right. And that's how you are going to solve a linear inequality. We are going to have a few more tougher situations, a few more tougher problems. So let's go through a few of those right now as well. So what we have is we are going to be having 2a plus 1 is bigger than 7a minus by 4 divided by 5. This is our next one we're going to solve. Same steps. Simplify both sides. If you want to simplify both sides, let's give it to the fraction. So let's multiply by the denominator. Remember, if you want to give it to the fraction, we multiply by our denominator. Distribute. So we have 10a plus 5 bigger than 35a minus, hang on, the 5 is the same as a 5, right? So we are left with just the numerator. So we need to make sure that we leave just 7a minus 4, right? If you multiply by whatever the denominator is, the numerator stays the same. From here, it's simplified. Now all we have to do is just move the x's together, move the constants to the other side, then isolate. So we're going to move the 7a to both sides, minus 7a. So we have 3a plus 5 bigger than negative 4, minus by 5 on both sides because opposite of a plus is a minus. So we end up with 3a bigger than negative 9. Divide by 3. Notice that 3 is not negative. If that was a negative, we had to flip the inequality. It's not negative, so inequality stays the same. So this is going to be a is bigger than, so we're dividing by 3, negative 3. Put it on number line, negative 3. It's not equal, so we have it open, and the arrow tells us to point it to the right. It's everything bigger than that value. Okay, part B. Same thing. Simplify both sides. Get rid of the parentheses. So we're going to distribute that 2 on both of these. We're going to distribute that negative on both sides. So we have, well, on the side that it is, negative 14b minus by 2 is less than or equal to negative 13b plus, because negative times negative is positive, 9. From here, let's get those variables together. I am going to move the 13b to the other side. It's negative, so we had to use a positive version. So plus 13b, plus 13b. So we have negative b minus 2 less than or equal to 9. Okay, well, let's go ahead and move that 2 over to get the constants to the other side. So we're going to add 2, add 2. So we end up with negative b is less than or equal to 11. Okay, we have negative. If we want to switch the negative to be positive, we're going to have to flip everything. So remember, this would be a b. Flip your inequality because we are technically multiplying or dividing by negative 1. Then this would be negative 11. Number line, put 11 on the graph. It can be equal, so we put a solid circle. And this one also points to the right. I just noticed that all my examples have it going bigger. And that's okay. Just know that if it points the other direction, it's going to be going in the smaller direction. Okay, from here, we have a word problem that we are going to work out. We are told that John has at most $30 to spend. No more than $30 to spend at the gym. He buys a bottle of water and a granola bar for $4. If the gym charges $7 per hour to rent the basketball court, how many hours to the nearest tenth can John rent the court? Okay, so we know that John only has $30 to spend. That's it. That's all the money he has to spend. That is a maximum amount. He cannot spend any more than that. Okay, so that means that $30, whatever he spends has to be smaller than that. Right? 30 is a maximum. It's the most it can possibly be. You must spend something less than that amount. Or equal to that amount. Right? At most. Okay. We know that he bought a water bottle and granola bar. So he already used $4 of that. Right? He bought a granola bar and water. What we are going to end up doing is I'm going to put this, compare the sides. So we are going to have one side, which is going to have how much he spends. We're going to have the other side, which is how much he has at most. So we know he spends $4, so that's a plus 4. And we also know that he is going to be charged $7 per hour for using the rental of the gym. So for every hour he's there, for every 7 times X, right? If he's there 1 hour, he's spending $7. For 2 hours, it's $14, and so on. So it's 7 times X there. And that's how much he's going to spend. So let's figure out how many hours he can actually spend at the gym. Same thing. We're going to end up simplifying by subtracting by 4. So 7x is less than or equal to, this would be 26. And then we're going to divide by 7. Okay, well, in order to find this, let's go ahead and do our division. 26 divided by 7. 7 into 26. This would be 3 times. That would be 21. Subtract, we have 5 remaining. This is going to end up to be a decimal. And it says rounded to the nearest tenth. So remember that. We want to round to the nearest tenth, so we need just 1 decimal. We're going to put a decimal, bring down the 0. 7 into 50. This is going to be 7 times. So this would be 49. Subtract, we have 1 remaining. Let's bring down 1 last 0. 7 into 10, that's just once. Okay, here's our issue. If we were somehow able to round up to about 3.8, if it was able to round up to 3.8, would he be spending more than that $30, or would he end up spending less than that $30? Well, if we round up in any way, he's going to end up spending more because he has to pay for that extra round. Okay, so whenever you're dealing with this type of situation, a real life application, ask yourself, if I round up, is that going to make it go over the budget? If I round down, am I going to be within the budget? Okay, so that's a good key question to ask yourself. So with this one, I know that it's a 1 and we would not end up rounding up anyways. But if you were able to round up, ask yourself the question, if I round up, does that actually make it so that I'm within the budget? Or if I don't round up, if I round down, am I within the budget? And that will tell you which way to round. Okay, so we have 3.7 hours that he would be able to spend at the gym. So that's the answer to this one. And I believe I have one last one. This is our last question that we're going to do for class today. Then we will end the recording. So we have Anne's phone plan. Costs $50 per month. This is an interesting phone plan because she's being charged for data. Most phone plans nowadays, the data, you get unlimited data, but she is going to be paying $3 for each gigabyte she uses during the month. So she has $50 base plan, then she spends $3 for every gigabyte that she uses. How many gigabytes of data can Anne use if she wants to spend less than $70? Okay, so she doesn't want to spend $70. She wants to spend less than $70. So this cannot equal. On her total phone plan, assume she must purchase a whole number of gigabytes. So no decimals. A whole number is no decimals. So what we're going to do is, let's pick out the information. We know $50 per month. That's how much she is going to spend. We know that it's $3 for each gigabyte. So we are going to add $3 for every gigabyte that she uses. Let's call that X. And we know that she does not want to spend more than $70. Right? So at most 70, not quite at most because we're not including 70 with this. She wants to spend less than that amount. So no equal to sign on this one. Solve it the same way we would solve a regular inequality. Subtract by 50. Subtract by 50. So we have 3x is less than 20. Divide by 3. So x is less than whatever 20 divided by 3 is. So we have 20 divided by 3. 3 goes into 20, that's less than 7, so that'd be 6. 3 times 6 is 18. We have 2 remaining. Let's put our decimal. Let's just get 1 decimal just to see where we're at. 3 into 20, again, that's another 6. We said that she can only have a whole number amount of gigabytes. So we want to make it no decimal. If we were to round this up to 7, would she be within her budget? Well, if we tried plugging that in, 3 times 7, 21, plus 50 is more than 70. So we need to make sure that we would round down in this case. Do not break the budget. Okay, so this one would end up we had to have it less than 6 gigabytes in order for this to work. By the way, this would end up to be or equal to 6 because of the fact that we could equal 6 and still be within the budget. So whenever we are writing our final answer, we will say she can use at most 6 gigabytes of data. And we will stop there.